Hey, my name's Erlen, and today I'm going to be talking about polymers and recycling. So, what are polymers? They're a huge chain of repeating units called monomers, and monomers easily bond with one another to form macromolecules. And this process is done by polymerization. And there's a photo for you here showing how you get from a monomer to a polymer. And so essentially polymerization is just the linking of molecules. So polymers can come in two different forms, natural and synthetic. The different types of polymers that you have, I just said natural and synthetic. So with natural, you can have plant-based, so that's cellulose, chitin, chitosan, lignin, starch. You can also have animal or human-based, so that's like collagen, DNA, silk, and wool. And then for synthetic types, we have polyethylene. An example of that would be plastic bags or films, bottles used in packaging. Polyester, you'd find that in clothing. It's got a high hydrophobicity, so it repels water really well, good for outdoor clothing. And then we have polypropylene, and it's a thermoplastic useful in labeling and textile industry. Then you have polyvinyl chloride, and so you've probably heard of PVC. It's very common in construction, plumbing. And then lastly, we have nylon, which is used in parachute manufacturing. So these are just a couple examples of the different types of polymers that you can have. There's way more out there. I thought it would be useful to include a few chemical structure examples. So I have here a natural polymer, chitin, and it's made up of repeating units of N-acetylglucosamine. Chitosan is a derivative of chitin, and it's made via the sodium hydroxide solution, a series of different washes. And it only differs here by the amide group, so the NH2. It still includes the N-acetylglucosamine. The structure is just a little bit more complicated, but relatively the same. Next we have lignin, and it is composed of aliphatic and aromatic alcohols. So aliphatic means it can have straight, branched, or cyclic hydrocarbons. And so the three alcohols that constitute lignin are para-humeryl, coniferyl, and synapsyl. And now we have cellulose, which is displayed for you here as A, and hemicellulose. So cellulose is a linear polysaccharide consisting of 1 and 4 linked beta D anhydroglucopyranose. And in hemicellulose, it's composed of several different sugars. So for example, xylose, mannose, galactose, and those are just a few. As you can see, it's highly branched. They're both extremely important in the rigidity of plant cell walls. The difference between the two is that cellulose is an organic polysaccharide, whereas hemicellulose is a matrix of polysaccharides. Here is an example of a synthetic polymer. And so starting out, we have a vinyl chloride, and after polymerization it creates PVC. What I kind of want you to take away from these photos is that they're all composed of hydrocarbons. So this huge long chain. They all have huge long chains of hydrocarbons. So how are polymers recycled? Well, natural polymers are easily degraded and taken up by the environment, and synthetic polymers are a little bit more hard to get rid of. So we have primary, secondary, tertiary, and quaternary. And those are the 4 ways that synthetic polymers can be recycled. So with primary and secondary, it's basically made up by mechanical recycling, which just involves heating up the polymers to a certain temperature so that their conformations change. And with tertiary, we have chemical recycling, and that's just chemically degrading plastic waste into monomers. We also have pyrolysis, and that's a thermochemical decomposition of organic material in the absence of oxygen. And lastly, we have the quaternary, so incineration, and that just basically involves combustion of organic molecules. So this is a pie chart just displaying the plastic that was recycled in 2011. The legend here just lists the high density polyethylene, the blue, low density polyethylene, here polypropylene, PVC, PS, PET, and others. How are polymers used in society? Well, in aerospace, glass fibers are used in a resin matrix. So resin is a synthetic polymer. It is a thermoset, which means that it can't be recycled. It just stays in its hard form. For agriculture, we have mulch films, siloplastic, and biopesticides.